up, everybody? This is Tech G back with another video. And in this video, I'm going to be explaining to you exactly what data encryption is. So let's get into it. Data encryption. This is a fundamental aspect of cybersecurity, essential for protecting sensitive information from unauthorized access. Now, with the increasing prevalence of cyber threats, understanding data encryption and its importance has become crucial for individuals and organizations alike. And in this video, I'm going to be breaking down exactly what data encryption is, its history, how it works, different types, benefits, challenges, real-world applications, and future trends. All right, so what is data encryption? So, this is the process of converting plain text data into a coded form, which is known as a ciphertext, and is used to prevent unauthorized access. And this transformation is achieved using algorithms and encryption keys. And only those with the correct decryption key can convert the ciphertext back into readable plain text. And here are the key characteristics of data encryption. So there's confidentiality, and this ensures that data remains private and inaccessible to unauthorized parties. There's integrity. This protects data from being altered or tampered with during transmission or storage. There's authentication. This verifies the identity of users and systems, ensuring that data is accessed only by authorized entities. And then there's non-repudiation, and this provides proof of data integrity and origin, preventing entities from denying their involvement in a transaction. All right, next let's go over the history of data encryption. So the practice of encrypting information, this goes back thousands of years. And here are some key milestones in the history of data encryption. So when it comes to early forms of encryption, such as a Caesar cipher, these were used by ancient civilizations to protect sensitive messages. Then in World War II, we saw the development of the Enigma machine, which was used by Germans, and its subsequent decryption by the Allies, which marked significant advancements in cryptographic techniques. And that image on your screen right there, that is a picture of the infamous Enigma machine. Then fast forwarding all the way to the 70s, this is the introduction of the data encryption standard by the National Institute of Standards and Technology, which provided a standardized encryption algorithm for securing digital data. Moving forward into the 90s, this was the development of the Advanced Encryption Standard by NIST and the introduction of public key cryptography, which revolutionized data encryption. And then there's the 21st century. So modern encryption algorithms and protocols such as RSA, ECC, and TLS, they have become integral to securing data in the digital age. All right, so let's talk about exactly how does data encryption work. So data encryption, this involves the use of algorithms and keys to convert plain text into ciphertext. So here's a simplified explanation of how this works. So there's the encryption algorithm. So an encryption algorithm, this is a mathematical formula used to transform plain text into ciphertext. And the common algorithms include AES, DES, and RSA. Then you have what is called the encryption key. So an encryption key, this is a piece of information used by the algorithm to encrypt and decrypt data. And the keys can be symmetric, which means they use the same key for encryption and decryption, or they can be asymmetric, where it's a pair of keys and one is used for encryption and the other is used for decryption. And then there's the encryption process. So the plain text data is fed into the encryption algorithm along with the encryption key. The algorithm processes the data, transforming it into ciphertext, and the ciphertext is then transmitted or stored securely. And then we have the decryption process. So the ciphertext is retrieved and fed into the decryption algorithm along with the decryption key. And then the algorithm processes the ciphertext, converting it back into readable plain text. And here's an example of data encryption. So you have the plain text statement of hello world. It's going to use the encryption algorithm AES with an encryption key that is 128 bits long. And then it's going to produce this ciphertext right here, which basically makes this completely unreadable. And then when it comes to the decryption, you just basically doing the complete opposite. All right, so let's talk about the types of data encryption. So there are several types of data encryption, each with unique characteristics and use cases. The first is symmetric encryption. And like I stated earlier, this uses the same key for both encryption and decryption. It is faster and more efficient for large amounts of data. And examples of symmetric encryption algorithms are AES, DES, and Blowfish. And then you have what is called asymmetric encryption, and this uses a pair of keys. You have a public key for encryption and a private key for decryption, and this provides enhanced security by eliminating the need to share the decryption key. And examples of asymmetric encryption algorithms are RSA and ECC. And then we have what are called hash functions, and these convert data into a fixed length string of characters, which is unique to the original data. And it is primarily used for data integrity and authentication rather than encryption. And some hashing algorithms are SHA-256 and MD5. And then you have what is called hybrid encryption, and this combines symmetric and asymmetric encryption to leverage the benefits of both. And this is often used in secure communication protocols such as SSL TLS. And an example of this is called PGP, or pretty good privacy. All right, next let's talk about the benefits of data encryption. So data encryption, this offers several advantages that make it a critical component of cybersecurity. The first is obviously that of data protection. So this ensures that sensitive information remains confidential and protected from unauthorized access. There's compliance. This helps organizations comply with data protection regulations and standards such as GDPR, HIPAA, and PCI DSS. There's data integrity. This prevents data tampering, and this ensures the accuracy and reliability of information. You have secure communication. So this protects data transmitted over networks such as emails, online transactions, and remote access. There's user authentication. This verifies the identity of users and systems, ensuring that data is accessed only by authorized entities. And then there's non-repudiation. And once again, this provides proof of data integrity and origin, preventing entities from denying their involvement in a transaction. So despite its benefits, data encryption also presents several challenges. And the first is that of key management. So securely generating, storing, and distributing encryption keys, this is crucial to maintaining the security of encrypted data. There's performance. So encryption and decryption processes, they can be computationally intensive, potentially impacting system performance. There's the aspect of complexity. So implementing and managing encryption solutions, this can be complex, requiring specialized knowledge and expertise. There's compliance. So ensuring compliance with various data protection regulations and standards. This can be challenging, particularly for organizations operating in multiple jurisdictions. Then there's encryption backdoors. So some governments and organizations, they advocate for the inclusion of backdoors in encryption systems, which can undermine security and privacy. Then there's data recovery. So if encryption keys are lost or compromised, recovering encrypted data can be difficult or impossible. All right, so let's move on and talk about some real world applications of data encryption. So data encryption is used in various applications across multiple industries. You'll find it in financial services, where it encrypts financial transactions and sensitive customer data to protect against fraud and data breaches. It's in healthcare, where it secures patient records, ensuring compliance with regulations such as HIPAA and protecting sensitive medical information. It's in e-commerce, where it protects online transactions and customer data, ensuring security and trustworthy e-commerce platforms. You'll find it being used in government, where it safeguards classified information and sensitive communications, protecting national security. It's in telecommunications, where it secures voice, video, and data communications, ensuring privacy and integrity in telecommunications networks. It's in cloud computing, where it encrypts data stored in the cloud, ensuring that only authorized users can access sensitive information. And you'll find it in personal privacy, where it protects personal data on devices such as smartphones and computers from unauthorized access and cyber threats. All right, so let's talk about some future trends in data encryption. So the field of data encryption continues to evolve with several trends that are shaping its future. The first is called quantum safe encryption, and this is developing encryption algorithms that are resistant to quantum computing attacks, ensuring long-term data security. Then you have what is called zero knowledge encryption, and this enhances privacy by enabling data processing and analytics without exposing the underlying data. Then you have what is called homomorphic encryption, and this allows computations to be performed on encrypted data without decrypting it, enabling secure data processing in the cloud. You have blockchain and encryption, so you can leverage blockchain technology to enhance data security and integrity through decentralized encryption solutions. There's IoT encryption, and this is developing lightweight encryption algorithms for securing data in IoT devices. And then you have artificial intelligence and machine learning. So this utilizes AI and machine learning to enhance encryption algorithms and detect potential vulnerabilities in real time. All right, so in conclusion, data encryption, this is a vital component of modern cybersecurity, providing essential protection for sensitive information in an increasingly digital world. By understanding the principles, types, benefits, and challenges of data encryption, individuals and organizations can better safeguard their data against unauthorized access and cyber threats. Now, as technology continues to evolve, the importance of data encryption will only grow, necessitating ongoing innovation and adaptation to emerging challenges and threats. So, whether you are an IT professional, a business leader, or simply a concerned individual, staying informed about data encryption and its applications, this will be crucial in navigating the complex landscape of data security.